Chapter 2, Section 4, Multiplication and Division of Integers. This, I think, is easier when you're multiplying than adding and subtracting with integers because I like the shortcuts better. But I'll leave that up to you once you get through it, whether you think it's easier or not. So first off, when multiplying and dividing, there's a little shortcut that is nice. When you have two numbers, so if you're looking at two different numbers and you're just multiplying two numbers together and you have the same sign, so for example, 3 times 5, our answer is 15, and the same sign, though this is a positive 5 and a positive 3. Or we have a negative 3 times a negative 5, you're also going to get the answer of 15. So I have the same sign, so positive for both or negative for both. You are always going to get a positive answer. If you have different signs, so you have one negative and one positive, you guessed it, you are going to get a negative 15. And again, if you have a positive 3 and a negative 5, you are going to get a negative 15 again. You're always going to get a negative answer. Every time you have that. So now let's think about this. If I have one negative, so that's my second example here, one negative, one positive, you're always going to get a negative answer. If you have two negatives, so that is my first example, positive 3 times a positive 5, you're always going to get a positive answer. If you have three negatives, so if I were to take my positive 3 times negative 5 gives me negative 15. If I were to multiply that by another positive, so positive 3 times negative 5 times positive 6, you are going to get a negative answer. If you have four negatives, you're going to get a positive answer. So when multiplying an even number of negatives, so 2, 4, 6, 8 negatives, is going to give you a positive answer. An odd number of negatives is going to be a negative answer every time, no matter what. So you can always count them up and figure it out. So now we do some mental math here. Yeah, you could do negative 4 times negative 3 and then do times negative 25, but that can be difficult. So let's think of this as a negative 4, a negative 3, and a negative 25. We said we could change the order of that because it's all multiplication. So what if you did a negative 4 times a negative 25 and then times a negative 3? When I think about this, I've got my negative 4 times my negative 25. That's going to give me a positive answer there because I have two negatives. My final answer I know is going to be a negative because I have that third negative there, an odd number. So a negative 4 times a negative 25 is 100. That was pretty easy to do mentally, 4 times 25. And then times a negative 3. Can you do 100 times 3? That is 300. And because we had a negative here, we have the negative in our answer there. So negative 300. So when we multiply, we can change the order. And we'd want to change the order if we wanted to make things easier for us. Well, now we're going to talk about division a little bit. And to do that, I'm going to use this thing called the inverse property of multiplication. So when you think about inverse, it's like the word opposite. So inverses undo each other. So if I ask what's the inverse of times 2, What are we going to do to undo times 2? We're going to divide by 2. So, examples here. 5 times 2 equals 10. So if I want to undo that, I would take my 10, and to undo times 2, I would 10 divided by 2 equals 5. I've done the inverse. The other way to think of that, to keep it multiplication, because I think multiplication is easier than division, we could say 10 times 1/2 equals 5 as well. So I took my 2 and I put it on the bottom there. And this as a fraction here is 2 over 1. And I took my 1 and it went on the top here. So I flipped over. Inverse, flip over. So now if we do 5 times 4, well, we know that that is 20. Let's make that 4 over 1. So 20 times what is going to give me 5? Well, the opposite, the inverse, the flipped over of 4 over 1 would be 20 times 1 over 4 equals 5. So I took my 1, it went on the top. Took my 4, it went on the bottom. So I flipped it over, I took the inverse. 6 times 2/3 equals 4. So 4 times what equals 6? Well, 4 times, I'm going to flip over my fraction. So 3 on the top and 2 on the bottom is going to equal 6. So inverse, flip it over. So now I have this thing called the multiplicative inverse. Little definition here from the book. A over B, so that represents any number over another number, is the multiplicative inverse, which means to undo, of B over A. So if you multiply A over B times B over A, they undo each other. Let's look at a couple, or an example of this here. The product of a number and its multiplicative inverse is always 1. So 2 over 3 times its multiplicative inverse, which would be 3 over 2. I flipped it. 2 times 3 gives me 6 when we multiply across the top. And 3 times 2 gives me 6. Anytime you have the same number over top of the itself, it's always 1. Try another one. 4 over 1 times, flip it over, 1 over 4 equals 4 over 4, which equals 1. So the inverse property of multiplication always is going to give you an answer of 1.